Greetings. Welcome to our 46th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we are going to focus on our January 12, 2023 webinar titled Positive Pressure Anaerobic Biogas Cover Systems. I'd like to quickly reintroduce our two excellent speakers. Brian Fraser has been working in the Geomembrane Institute for over 40 years, including manufacturing, fabrication, and construction. He's currently Vice President of Layfield Geosynthetics and responsible for business development in the U.S. and internationally. Our second speaker is Steve Valero, who is an independent construction, manufacturing, and civil engineering executive with over 25 years of experience in engineering, manufacturing, management, operations, industrial property development, and business development, as well as construction product research and development. He has expertise in floating covers, flexible cover containment systems, earth retaining structures, and so on. So, Steve and Brian, thank you so much for joining us following your webinar and to answer some follow-up questions that we did not get to at the end of the webinar and that we received after the webinar. Okay, so first, questions from the live webinar that we did not get to. Question number one, how can an in-service cover, say after 5 years, be assessed for leakage? I'm assuming it would be dangerous for someone to try to walk on it to look for leaks when it is in operation.
Well, I know, Tim, again, from a service point of view, these covers should have, annual inspection and maintenance performed by a expert QCA company or liner installer. There are portable methane gas monitoring systems that can be scanned over the cover system, or technicians can walk the cover with portable gas methane detection systems. And again, all repairs need to be you need to obviously be very up to speed in terms of safety requirements with equipment, etc. We normally can walk on these covers if they're designed properly, and Steve will talk about that, ballasted properly. We commonly walk on existing covers for maintenance, etc. But like any cover system, it really depends on the design and making sure that the material still has a lot of its strength to walk on.
Okay.
And I would agree with that. Just to add that during the design phase, the weight of humans walking on these localized areas of these covers is really low compared to the design stresses, I guess, that you would consider when designing these covers. But as Brian had mentioned, really the key is health and safety, and make sure that the personnel involved in this are aware of the dangers, understand areas they should and shouldn't walk, and obviously have proper PPE and fall protection and other equipment that might be involved in getting to the areas of the cover to do a proper maintenance survey of that cover.
Okay. Next question from the live webinar. How is a constant pressure at about a ½ inch of water column typically maintained in these systems?
Yeah, so I guess I'll start with that, Brian, and just to mention, again, from the design side, it really varies. It varies by the operator, and in terms of maintaining the pressure or design pressure inside that cover, it really depends on the takeoff system and the venting system that goes out. It's where the professionals involved in the cover design need to work together to make sure that the takeaway system for the gas is designed to maintain that pressure level. And so whether it's a half an inch or more or less, whatever design pressure was intended to be maintained inside that cover, there needs to be, first off, the takeaway system should have a monitoring system that automatically regulates that cover. And in times where if the pressure would go past certain maximum design levels, then there should be venting occurring that would pull, reduce that pressure, relieve that pressure in a emergency situation before it became overwhelming and obviously did damage to the cover or created a dangerous situation. But again, it's really a combination of the normal takeaway system and then some emergency monitoring and venting systems that would combine to regulate the cover within, regulate the pressure within the cover so that it doesn't A, become dangerous, and B, damage itself by exceeding the maximum design pressure that could be accommodated by the system.
Okay. All right. Brian, anything to add, or should I go on to the next question?
I think we're good. Good thorough answer.
Good. Great. Thanks, Steve. Number 3 from the live webinar presentation. Last question. How do you deal with rain runoff from the cover?
And I guess I would just echo, again, this is something that depends on the operator heavily, but in most situations, you would design the cover such that it would have a natural slope to it and the water would run off because they do tend to balloon up in these whales, as we refer to them for lack of a better term. And so that in a properly designed cover, it should have a constant slope from the center to the edges that would allow water to run off. Sometimes because of all the things that we mentioned in the original webinar, where you can have, there's potentially overstressing of the liner where it's surpassed its elastic limit and may have some slack built into certain areas, and also lack of completely consistent tensioning during installation. You can have areas that would hold water. And for the most part, it would tend to either evaporate to go away, or if it became an issue and an operational issue, it would require submersible pumps to be placed on the cover to remove that water. But in most, and Brian, I'm sure you've seen more of these than I have in the field, but for the most part, there's no active system maintained or placed on these covers to remove water. It's simply either runoff or evaporation, unless it would become a problem to where it's depressing that cover too much in a particular area, and then it's likely the operator would need to put some sort of a submersible pump in there to mechanically remove that water.
Yeah, I agree, Steve.
Okay, questions submitted after the live webinar, and these questions were submitted via the post-webinar survey. Number 1, can bituminous geomembranes, or BGMs, be used as a cover? Is there any concern regarding bitumen getting dissolved or softened by methane? And there might be a hole due to thinning of the cover material over time. Kindly let me know your expert opinion on using BGMs, bituminous geomembranes, for a biogas cover system.
So I'll try to take a shot at that, Tim. I am familiar with the bituminous geomembranes. To my experience in North America and internationally, I've not seen it used in any type of cover system, whether a floating cover or a biogas cover. Typically, again, it's a material used in, we see it more in some remote areas where subgrade preparation is difficult, and that's where we see it in mining applications, etc. On a cover system, I guess the concerns would be it's a very heavy material. We are normally joining it on site with a open torch system. So of course, the material is very heavy. It would be certainly a safety concern to be using that type of field welding on a methane digester, and of course all the concerns with safety explosions and all of that. So to date, I've never seen a BGM used. I do recommend if it is to be considered both either as a liner or a cover with methane, that as we talked about in our webinar, it could be a material tested with the this new GM 35 standard that's testing materials for methane and UV and pressure as in the application of digesters.
Okay.
I would just add, from a design perspective, I personally wouldn't design a cover system with a BGM material. I just don't think it's an appropriate application of that type of material.
Okay, great. Second question post-webinar is, are drones used to perform visual defect and gas leak detection for these biogas covers?
Steve, I don't know if you have any expertise on that. I really can't comment.
I don't. I'm certain they could be. It's certainly they're replacing humans in a lot of aspects of inspection, and especially in dangerous or difficult to reach locations. So I don't have any personal experience with that, but I'm certain that a drone could be adapted to at least do a visual survey, and even possibly mount some sort of gas detection equipment on and pass over the cover, but don't have any direct experience with actually having done that or seen that done.
Okay, number 4. How are the inert accumulation removed from the digester for a CAFO operation?
Yeah, so this is it's more of, again, it's one of these places where the various disciplines involved in design have to make sure there's cooperation, but this would really be up to the digester designer and not necessarily the cover designer. But they do typically have sump areas and the ability to pump solids from those sump areas within these digesters. But there are several different types of designs out there on the digesters themselves that allow removal of inert solids and cleaning of the base. And they just vary widely by the designer and designer preference on the digesters, but it's really outside of my expertise in terms of the operation of the digester itself.
Okay. All right, Brian, anything on number 4?
No, I think Steve's answer is appropriate.
Great. Okay, number 5. Do you think ballast is needed for a 60 mil textured HDPE geomembrane cover for these biogas systems?
From a design standpoint, I'll just say that the dependence of ballast is really based on the wind loading and environmental loads, and also the operational pressure or the necessity of ballast, I should say. So it's not necessarily dependent on 60 mil textured versus 80 mil smooth liner or whatever it might be. So you really have to take into account the geometry of the system, the expected environmental loads, the operational pressure, and so it's not a question you can just directly answer based on the type of membrane being used. And then I think Brian also probably has some comments on whether textured is normally used or appropriate. I know in design, I wouldn't typically design a cover with a textured membrane. It's really not necessary there.
Yeah, I agree, Steve. We have not seen, I have not seen any actual projects or specifications looking for, a textured geomembrane, with high asperities, etc. So typically not common at all, and probably even from walking on these the covers, though they do balloon up, the slopes angles aren't that steep, so you can normally walk on these covers. Again, as any cover, you need to be careful with wet areas, etc. But we have not seen texturing required in any material specifications that we've been involved with in say the last 10 years.
Yeah, I should also mention there might be some confusion with the type of this. This is an exposed cover, so they're not soil layers or anything resting on it that would have an interface friction issue either. So to clarify, in an exposed and under this particular webinar, we were talking about pressurized. cover systems, there's really just no need to have a textured membrane. And then the question regarding ballast, it really depends on all the other factors that I previously mentioned.
Okay, great. Last question from the post-webinar survey. In a lagoon digester design, considerations for cover ballasting systems and anchorage are used. Tires, sandbags, okay for this system? Or if not, what would you use?
Yeah, there's really no preclusion to using anything that can act as a weight, a ballast weight. So, if tires are available, sandbags, whatever it might be, those are certainly could be used in that application. The concerns would be you have to make sure that the ballast is maintained in terms its physical location is maintained on the cover system, because as these things balloon up, they would tend to want to slide and move around. And so they would have to be, for instance, if you use sandbags, they would normally need to be secured with some sort of cabling or welding straps to the cover. And the same would go with tires, just to make sure that they don't move around too much on that cover system as it tends to balloon up. And then, what's typically used, though, is what we really showed in the webinar, which is mostly they would take a polyethylene or pipe system, a flexible pipe system, and then fill it with water, or preferably a grout type material that would provide some more mass to it to help with the ballasting, and then also give the ability to maintain its location by welding it down with straps and then securing the ends with cable. So that's what's typically used. But again, tires, sandbags, anything that provides weight could feasibly be used as long as its location could be maintained.
Okay. All right, good. Brian, anything to add before we end?
No, nothing in terms of that question. Just best practices to make sure you have good ballasting. Is we see a lot of the pipe systems with structural grout and designed around proper or spaced properly in terms of grids to handle the internal forces, or a strapping system. The one thing we do know, Tim, as we've learned, is that there's different systems being used in Europe and South America and North America, but they all still rely on some form of proper design structural ballasting.
Okay, great. And of course, listeners, there's a new FGI guideline on biogas cover systems on the FGI website at fabricatedgeomembrane.com. It's over on the right under resources, guidelines. So you can get some additional information there. So thanks to Brian and Steve for joining us again from Brian's in Yuma, Arizona, and Steve's in Knoxville, Tennessee, and answering the follow-up questions we had on your webinar. So thanks, everybody. If you have additional questions, please email fabricatedgeomembrane@gmail.com, or you can also download the webinar slides from the FGI website as well. Okay, Brian and Steve, thanks so much for joining us.
Thank you.
Thank you very much.